Welcome to those of you that are here tonight and also those that are joining us on our YouTube channel. My name is Carl Dobman and I'm the Dean of the College of Architecture and Design at Lawrence Technological University. At the college, we believe that the future of design is multidisciplinary, and we host a range of design degrees that include graphic design, industrial and transportation design, game art, interiors, architecture, and urban design. We track design future trends, emerging technologies, and advancements in practice as a means of crafting education approaches in these areas. Our lecture series allows us to engage these multidisciplinary design discussions and offer broad perspectives on where we're heading. Our next lecture, not tonight, but in 2 weeks, will be February 19th, and we'll be hosting Laura Forlano. Her lecture is titled Careful Futures, Design, Technology, and the More Than Human. The lecture is co-sponsored by the Humanity and Technology Group at the LTU College of Arts and Sciences. But you're here tonight to see Michelle. So I'm very excited that Michelle is able to visit us tonight in Detroit, although she has a cold.
I have a cold, I have a cold.
So she's probably not so happy that she's traveling. But I did the math and I realized that I've known Michelle for just about 20 years now, which feels very strange to say and makes me feel old.
Not nearly as old as I feel, but.
So as a means of positioning her talk and the introduction for her, I was thinking back to the class that I took with her, and I was reminded of Clarke's laws. Sir Arthur Clarke was a British author, inventor, philosopher, and futurist. He's best known for his short stories and novels, among them 2001: A Space Odyssey that was written in 1968. He was focused on the future and viewed it with anticipation and optimism. And he created 3 laws. The first law: when a distinguished but elder scientist states that something is possible, he or she is almost certainly right. When that scientist states that something is impossible, he or she is very probably wrong. The second rule: the only way of discovering the limits of the possible is to venture in a little way past them into the impossible. And the third rule is any sufficiently advanced technology is indistinguishable from magic. And the reason why I share these laws is that in graduate school, I took a class with Michelle, and this is a way to think about some of these things. For the first meeting of the course, and the course was in smart materials, Michelle took us to the library where there was an exhibition of the history of magic. Michelle is amazing in this way. She's able to dive so deep in math, science, engineering, while at the same time able to engage the arts and far-ranging topics, like in this case, magic, as a way to push the limits into the impossible. I think you also paint too, is that right?
No, I'm a musician.
I thought, but there was this really great podcast. Weren't they talking about how you were a painter?
I used to teach painting, but I was not a very good painter. No one knew I was an engineer. They let me teach painting.
Her list of accomplishments and awards is way too long of a list in a format like this, but I'll give you a couple of highlights. Michelle received a BSME from Tulane, a BArch from Temple, an MDes, and a Dr. Des, or a DDes, from Harvard. She also holds an honorary MA from Yale University. Originally educated as a mechanical nuclear engineer, she worked for several years as an engineer at NASA and at DuPont before she studied architecture. And by special request, she included a special picture of her when.
I couldn't find it. I'll send it to you. I'll send it to you, yeah.
I've had her lecture before, and she showed an incredible picture when she was working at NASA. She served as the Gerald Hines Chair in Sustainable Architecture at Yale. She's also taught at Harvard, Technical University of Munich, Temple University, and Philadelphia University. In 2009, Michelle was selected as one of the country's top 10 faculty in architecture by Architect magazine. She's an incredible teacher, and that award was so well deserved. Currently, Michelle is the Dean at the University of Texas at Austin School of Architecture, where she holds the Henry M. Rockwell Chair in Architecture. As you can tell, I am very excited to have Michelle with us tonight, and it's my hope that you find her as amazing and inspiring as I do. Please help me welcome Michelle Addington.
I want to give him a big hug, but I have a cold. I don't want him to get sick. And actually, it's ironic that you brought that up, that time up, that I decided to foray into magic. We talked to Ricky Jay. It was really kind of an incredible opportunity and time to sort of step away from so many of the things that we were thinking about advanced materials, that there was a stunning tradition in the 19th century that things like thermochromics, a whole series of things that we think of about being new today, were things that they imagined. They didn't have, they simply imagined that. And there was a series of these types of sort of demonstrations, and all of them were based on physics, making color change, making those things happen when indeed they actually weren't really happening. They presaged a lot of these really advanced materials. And one of the reasons I was so interested in doing it in that particular class was that we have a tendency when we're dealing with technology to kind of want the technology to be this heroic answer, that we can't do this thing unless we adopt this particular technology. And what the whole point of that particular class was back then was it's all possible. It's all possible if you actually understand perception, you understand the physics of how things work. So before I get into what I wanted to talk about today, I just wanted to rub in the fact that I took this photo on Tuesday in Austin. We have, the School of Architecture has 4 historic buildings by Paul Philippe Cray and Cass Gilbert. And the saucer magnolias that you see there have actually bloomed a while ago. They were just starting to drop their leaves. So that's how far into spring we already are there. But it's a pretty fabulous place. On the other hand, don't ask for any kind of photo or explanation from August. You will not want to be there in August. What I wanted to talk to you about today, and I think Carl has known me for so long in terms of talking about advanced materials and technologies, that he may not realize or may not have wanted me to talk about the other half of what I deal with. And that was, when I was teaching and taught for many, many years, I was always sort of teaching 2 things. One, I had to teach environmental controls. And the other, I would teach, these great seminars in advanced materials. So particularly in the environmental controls, when you're dealing with questions about energy and sustainability, I would find that those would be classes that would attract, engineers would come to the classes, anybody interested in sustainability would come to the classes, but nobody interested in design wanted to take those. Everybody tried to find a way to sort of get a waiver from that particular class. On the other hand, for the seminars and materials and technologies, that's what all the designers wanted to take. And as a matter of fact, it's Carl's fault that Harvard has a completely new system, or developed a completely new system for seminars. After I met Carl, I wanted him in my class. And Harvard students protested that he took a spot. He was an MIT student, protested that an MIT student was taking away a spot for them. And so starting the very next semester, Harvard started a lottery system for people to take advanced seminars. So that's all on Carl. But nobody interested in energy or sustainability would even shop that class. They wouldn't show up for the first part of that design class. And what I've always tried to explain to students, they're one and the same. If you really, really understand how things work, all of that is within your wheelhouse. If you really understand how things work, you will do so in the way that's most efficient, most effective as possible. If you really understand how things work, you can work with any technology, you can work with any material and do almost anything you want to do. So I was part of a really very peculiar conference call 2 weeks ago. And it was a conference call between all the Ivy League schools and me. I got to be token now that I'm in Texas. And it was about, how are we going to address sustainability now? Nobody's really doing that much different. What's the way to address it? And the near universal agreement on this conference call, near because I was not in agreement, the near universal agreement was like, we got it. It's just make people use CLT. And when it comes to the rapid urbanization taking place around the world, we're going to have biological and degradable materials for that. That'll solve that. And I'm thinking, who am I talking to? Have I been away from the Ivy League for a year and a half that I thought, this isn't even rational, to think in this way. It's also not very interesting to think in this way, that there's two very straightforward ways that we go forward. We just have to adopt them. And again, the onus on adopting them is always on somebody else on that. And I started thinking about the way that we've thought about sustainability in architecture, and I'm really just going to put it into three different periods. There was the period about passive systems, the idea that it was all about the form, of the building, and we ended up with a lot of stuff like this. Of course, that had its backlash. That had really quite a response, as you can imagine, from certainly who would consider to be the movers and the thinkers and the shakers and the theoreticians and the stars of architecture. But a lot of the reason there was a backlash, this also didn't work particularly well. But nevertheless, there was that belief that form was all you had to deal with in terms of building something that was very, very sustainable. Then it went into the best practices mode, which ended up with building codes. I've always been interested that when you talk to, particularly in that time period, when you talk to groups of architects about what we need to do, they'd almost automatically say, we need more building codes. I don't think they would ever say that about anything else, but they'd say for energy we need more building codes, as if it's just like you got to make people do these things. And I don't have it here, but I have sort of a progression of building code changes due to energy, fastest rate of change in history. Building codes, the typical state in a 10-year period went through 3 code changes. You think about how long we've been dealing with plumbing codes from like the 1940s. To think that 3 code changes in 10 years for energy codes, as everybody was pushing for the codes. And of course, the same time we were dealing with this sort of the code thing, we were also dealing with rating systems, qualitative systems and things like that. And then the next thing that came along was the technological solution. The things we put on a building. So it wasn't even getting to be about the building anymore. It was going to be about the things we bought for the building, the things we added to the building on that. And so that's really kind of the phase that we're in right now. And I find that when I talk to different firm leaders out there, different practitioners out there, nobody's greenwashing anymore from the standpoint of sort of overstating what things are. It's just like, this is our landscape. This is what we do. This is about as far as we can go, and we're doing the best we can, and this is what we're told we need to do on that. And this has really troubled me for quite some time. And so I started trying to kind of peel apart, how do we end up in this particular situation? And what you'll see in here is a series of sort of different things that I've identified over the years as kind of where we had misdirections, within this, where we might have been indiscreet within this. But the fact is that each one of those things kind of allowed us to avoid actually addressing the problem of what the actual environmental consequences are of our buildings. With lots of things allowed it to, and a lot of it not through any kind of deceitfulness or disingenuousness or meanness on our part, a lot of it due to misunderstanding, misassumption, misattribution as we go through. So I just wanted to show real quickly this particular slide. This I got from the United Nations Sustainable Buildings and Climate Initiative when I did an event with them a number of years ago. And what they're identifying here under the buildings, so the buildings is where the big red oval is that's where they identified as, you want to do something about greenhouse gases, guess what? Just focus on buildings. That's where all the potential is going to be. And part of where they were getting that potential, some of you would have seen, this McKinsey chart. So what they're talking about here is, what is the low-hanging fruit? Low-hanging fruit is everything in green. And the idea is that you do any of the things in green, save greenhouse gases, and you make money. And if you notice on that, all building stuff, with the exception of fuel-efficient commercial vehicles and sugarcane. Everything else has something to do with a building on it. So everybody has this in their mind. And while I was doing this event with the UN, one of the things I started doing was reading all the documentation of different countries and different agencies, had about buildings, building energy and things like that. And one of the things that I was reading through this, I saw it didn't matter if I was reading the plan for India, I was reading the plan for the United States, I was reading the plan for the United Nations, there was a sentence that showed up in every one of them. And it was this sentence: energy consumption in both new and existing buildings could be cut by an estimated 30 to 50% by 2030 through readily available technologies, design, equipment, management systems, and alternative generation systems. And it continues. I sit on a board at Princeton, and this was 2 years ago or 3 years ago that I heard, I see 4 years ago already, wow, time goes, flies. I heard the Undersecretary for Science and Energy talk about building energy efficiency, says the same thing, 20 to 35% in there. And this was something that I said, where does this come from? Why is everybody using this? Because it was kind of like a little bit suspicious to me that India had the same statement about technology that Germany did. What was going on here? And it took me a while to get anyone who bothered to attribute the source. And I finally did a complete paper trail. And it took quite some time to hunt down the paper trail because somebody would cite a source, but it wouldn't be the original source. So actually finding the few things that kept citing back, if you follow the paper trail, it goes all the way back to a 1980s study of 12 homes in suburban Los Angeles, built by the same builder, looking at a suite of things for these particular suburban homes in this particular suburb, made by this particular builder, and comparing them. And again, nobody was disingenuous. It's just that every time, so in that comparison for those 12 buildings, they got that 30% number out of it. It's just that every time it got cited, information got dropped off, till it goes from being 12 buildings to the entire world. Now, this is sort of thing. And so you have policy worldwide that's being decided on this kind of information. And I would say this is not an exception. Our field in particular is really fraught with this kind of information of things that sort of gets dropped a little bit, not carried all the way through. Many of us, and I'm going to put myself right in the middle of this because I do this too, we're in the set of fields that we have great breadth of knowledge. We have great breadth of sort of understanding different types of things that we integrate. We feel very comfortable appropriating knowledge from other fields. And we have that tendency to say, I can pluck from there, I can get that, I know what's going on there. I do that an awful lot. And so this is what happens in our field, is that we don't actually have sort of the deep expertise that would let you know there's something really problematic about that statement. But it continues in many different ways, and this is one of my favorite examples. Those of you in here who've studied architecture all know this building. in Houston, the Menil collection by Piano. And there's an iconic image that goes along with it. It's this one right here of how the louvers work. When I first started teaching the dreaded environmental systems class, and I asked for some advice on how to teach it, it was said, oh, you know, and particularly the lighting part of it, because I'd never taught lighting before, it said, oh, this is such a great precedent, you know, have the students model the louvers. And I'm thinking, you know, I'm actually a pretty good engineer. This cannot work. This is a really bad idea for Houston, Texas. This cannot work. And so I got a small grant, and I went down to Houston to take a look at the building. And anytime I look at a building, I go on the roof, and I also go through all the mechanical systems. So that's one of the advantages about having a mechanical engineer half of me, is that I get to go into pretty amazing spaces within buildings. And so that's what happened there. So I'm gonna show you some poor quality images because this was a long time ago. And so I tried to digitize the slides. They didn't digitize particularly well. But what you find when you're on the roof are a series of panels. And depending on where you're looking, some of the panels, what we're looking at right here, some of the panels cover a whole section of the roof, but they're strung like this. And then if you go inside, you begin to realize what's going on. The only place where you actually had the louvers working as they were designed was the lobby, the corridor, and then wherever there was stuff that they considered to be non-fugitive. Non-fugitive means it doesn't sort of, it isn't damaged by ultraviolet. So that was stone, like stone sculpture. So the sculpture gardens and things like that had that. Every now and then in a space, most of it be covered, but they'd allow a little bit of washing. Little cracks that allow wall washing, and then wherever the good art is, it's just also sort of like sheetrocked on the inside of that. And the funny thing about it is that, you know, you don't have to climb up on the roof to see this. You can see it when you walk in. You walk in, you should notice these types of things. It's clear that as it's starting to move away, this is the entry lobby. As you're getting away from there, that's where it starts being covered on the roof. Does anyone know that? No, everyone thinks the louvers work in this particular kind of way. So it's this kind of thing that we attach effect to the things that we make. We attach effect to the surfaces that we make. We assume that things work in a particular way, and yet actually never sort of, in the same way that we didn't trace the source, the paper trail, of those figures all the way back to that it was 12 buildings. We also don't sort of like trace, what is the physics of this? How does this really work? Could this work in this particular way without actually wildly overheating the building? You know, another one like that, now it's another art museum, but on a different part and for a different reason. This is the Lou Kahn, last Lou Kahn building. He died while this was under construction. And this is the Yale Center for British Art. And this revolves around one of the skylights within this. Little known to those of us who were teaching at the School of Architecture, well, we knew that there was an upcoming major renovation of the building. What we didn't know is that they had planned to completely rotate the skylights during the renovation. There had been a long-standing belief that the skylights had been installed improperly, that they were facing the wrong direction. The skylights face south, so let south light in. And so, again, we didn't know at the School of Architecture they were planning on rotating the skylights to the north on this. And about the time period they were considering doing this, we had mounted a show, a really amazing exhibition. I'm going to guess no one in here has heard of this person, as I didn't hear of this person until we did this thing. Richard Kelly, greatest lighting designer of the 20th century. Every great mid-century modernist icon he was a lighting designer for. All of Kahn's buildings, by the way, he did the lighting design for. All of Saarinen's buildings, Van der Rohe's buildings, he did the lighting design for. And one of the things that we're very fortunate to get for this exhibition is his daughter had saved all of his notebooks. And there was a notebook entry, and we happened to mount it in the exhibition, that explained why the skylight had to face south. And so the director of the British Art Center was reading that, and she came to me and she said, we were going to rotate the skylights to face north. This note of Richard Kelly's from his notebook says they have to face south. I said, well, yes, of course. And it says, no, that doesn't make any sense. And so I gave a class. I went over there. I gave a class to all of the museum directors at Yale and to the different curators on what the problem with the north skylight was. And it has to do with the way the sky is blue. And the issue with the way the sky is blue is that, and this is sort of a very quick thing on that, is that the way scattering works is that you have blue everywhere. And then as you start moving closer and closer to the sun, you start adding in other wavelengths into it. So what that says is that if I take a lumen, 1 lumen of north light, it will have more ultraviolet and more damaging blue. The most damaging thing to any kind of painting is going to be ultraviolet. Blue will be next. You know, the least damaging is red. You know, that's why when you go into many museums, particularly ones that have things like works on paper, as well as very fragile textiles, those rooms will be on the red spectrum on things. So the last thing you want is full north light with the blue. So on a lumen by lumen basis, north light is way more damaging. People used north light for a long time because they weren't able to manage it on a lumen by lumen basis. You know, because if you think about a square foot of south light versus a square foot of north light, a square foot of south light, of course, has more total blue or more total ultraviolet in it because it has 10 times the lumens in it. But we don't design that way. We don't design by a square foot of aperture. We design on a lumen by lumen basis. So a lumen of a south light has about 20 to 30% less of the damaging light, blue, than does the a lumen of the north light. So I gave that, and they got it, and they agreed not to move, rotate the skylights. And then about 2 years later, I got invited to the opening of new conservation facilities at Yale. And they walked me around, and they proudly showed me all their north-facing skylights. And you can even tell, look how blue. You know, look how amazingly blue these skylights are. And I said, wait, you were in the front row when I lectured on this. And he goes, well, I thought you were only talking about the Yale Center for British Art. I said, no. I was talking about the Northern Hemisphere, the entire Northern Hemisphere. And then the response is that, do you have a research paper that explains that? And I said, it's a textbook would explain that. That'd be like asking if I could dig up a research paper that explains gravity. This is just how things work on this. But he really argued with me. He says, you know, people have always used north skylights. There must be a reason. I said, there are reasons. There are reasons when you didn't have the kind of ability to control the distribution of the light. There were a lot of reasons for that. The fact is that if you're dealing with any of the direct light, it's highly problematic. We can handle all that now with a lot of our different types of light redirection systems. And so surely you can understand that's why people did that. And because I'm very suspicious on that. But it was this deeply held belief. And I'm just trying to think, we're doing a renovation at Texas. At one of the museums that we have on campus. And the same thing, the architects came in, we're going to install some north-facing skylights. And I brought this up, they're very problematic, because do you have a research paper on that? That I don't know what I'm going to do on this particular one. But this is these things that we believe very deeply to be so, and we want what we expect in order to challenge that are often rather peculiar things. Like I said, a research paper as opposed to the fact it's fundamental atmospheric physics. One of the things that I have been really interested in, so I'm originally a mechanical engineer. I actually spent most of my undergraduate in nuclear engineering, but ended back up in mechanical engineering. And I've never really understood why we think about thermodynamic behavior of building the way that we do in architecture. And it finally occurred to me it's because of the way that we study structures in buildings. That there's a particular way that we think about structures, this sort of manifestation of forces, and the fact that those forces manifest on the things that we make. So if I think about a force diagram, I think about the things that we make and how that force diagram manifests within that. And it doesn't matter how complex it is, I understand a force diagram. It's one and the same with the things that I make. And so we take something like a thermodynamic system, and we look at sort of a simple drawing of that thermodynamic system, which is about, again, also how forces exchange at a boundary. We want it to look the same way and behave the same way as a structural system. So we map it in exactly the same way. We think about how does that make sense on this? That you want to ventilate as much as you can at the same time, make it as tight as possible. And again, that's all based on this idea that everything sort of happens with the thing. Did I do something? The battery's dead, okay. I'm not going to let you touch that back there. Okay. I totally lost my train of thought. But we end up trying to sort of map these things onto what we know, and it doesn't matter if it's this example or it's this example. Same idea, trying to map it onto the things that we make. But if I come back to this sort of classic drawing of a thermodynamic system, how does that actually manifest? This is the best illustration of how it manifests. That's about how it functions. That's how it works. It's completely contingent. It's not fixed to a thing or an artifact. Instead, it sort of follows behaviors within it. And so we're caught with sort of like, trying to read things and interpret things through that which we know. And for us within our field, that which we know is what we make and what we draw. And we want things to sort of like respond directly to it. We want light to be understood through the things that we draw. Light's a micron scale behavior. It has very little to do, interestingly enough, with orientation and all the things that we deal with. It's a micron scale behavior. I can make light move in any direction for any length and any distance that I wanted to. I don't have to move a whole building, in order to do that. Yet we have that sort of sense that we want to have everything attached to the things that we make. And then this is sort of the last one like this, and it's my favorite one. And I don't know if you ever had a chance to meet Joe Paradiso at the MIT Media Lab when you were there. But while I was trying to figure out how to teach this course in smart materials, there was a guy over at the Media Lab doing some work on it. And he's the one that first talked about the piezoelectric shoe, the shoe that you'd wear, and then of course you'd make some, energy by stepping on the shoe. I guess the shoe stepping on, whatever. footfalls would make energy. It was a fun project for Joe. They had some great laughs with it. But a lot of people really got excited about it. And then everybody started hearing about this subway stop, or subway turnstile in Tokyo that supposedly had these piezoelectric pads and was making all kinds of energy from that. And it really sort of like swept from there. You know, this particular floor that supposedly, if you danced on it, it would light things up. And then suddenly you're seeing headlines everywhere. That you're going to make all of your own energy simply by putting in these particular floor tiles. Now, this didn't bother me nearly as much as the 20 to 35% saving energy, but it really bothered a friend of mine who specialized in making piezoelectrics, and she said, no way. This cannot be so. Mechanical engineer, professor at Yale. So she built an installation. This is outside, you can't tell, but it's a Breuer building, outside of this Breuer building. And she's one of the one of the most advanced researchers in piezoelectrics, so she knew what she was doing. Did a whole variety of different tests of footfalls, how a foot landed on a tile, what the weight of the person is, a whole series of things like that were tested on that. The conclusion at the end is that, yes, you could make some energy from this. If you took these tiles, put them in Times Square in the busiest intersection you had, by the end of the day, you might be able to turn on an incandescent bulb on this. But that was about it. It was a minuscule amount of energy coming to it. It didn't stop, actually, one of my counterparts from Yale from displaying this, getting the Rosengard floor at the Venice Biennale, and she was so excited, and she explained to me, Michelle, for you, we wanted to make sure we were showcasing a great new way of saving energy. You may not have heard about this. And yes, I have heard about this one. But again, it was this sort of like desire for there to be this answer. If we just had this technology, it would solve this. So I'm left with some of these lessons as I've been thinking about this. What are some of the lessons and what are some of the possibilities, you know, in moving forward? I think for me, the first lesson, it's maybe not a happy one for some people, but there aren't any heroic solutions. You know, there's CLT is not going to save the world. Building materials made out of mushrooms will not sort of like revolutionize what we're doing in the developing world. You know, I would love it if indeed there were, but there simply are not heroic solutions. And if we think about them, instead of being heroic, they're the easy way out. And not only are they an easy way out, but they take a lot of responsibility off of our shoulders as architects. You know, if it's really only about buying this material or buying this technology or buying this system, it's basically relieving me and you of the responsibility of rethinking what it is we're doing. So some better questions, and this is actually just now coming in the last few weeks, so these questions aren't that good, but it's sort of a start of trying to pull together some of the questions. This is a question that I've had for a really long time, that, you know, I have never understood an HVAC system. I hated that I had to teach it for years. It was the type of thing where, you know, I'm teaching how they work, I'm teaching everything behind it, thinking, how do we end up with such a bad technology, such an archaic technology in our buildings? It makes no sense. I mean, it does when you look at the history of it, because the history of it is astonishing. Why we did end up with the HVAC system. Again, had nothing to do with its actual effectiveness, had to do with some of the, it had to do with the 1918 flu epidemic. There's a whole series of things that came into play that kind of ratcheted it into place, and we haven't been able to dislodge it. But we've not really been trying to dislodge it either. The human body, You know, we think about this particular space, the fact that it's so well mixed that the air temperature is controlled all the way through. None of us are floating above our seats. You know, none of us are in sort of the nether regions of this particular space, and yet this is fully diluted, fully conditioned, and fully cooled. The stunning wastefulness of doing this is shocking. And of course, if we think about the fact that just the fan energy alone and what that takes is an unconscionable use of energy on this, to do nothing. All of the body's energy exchanges happen either through radiation, which is over great distances and not through air, or through convection next to the body, which is a millimeter to a centimeter away from the body. All the rest of it is not meaningful in there. And it interests me because there's plenty of ways of doing this, plenty of ways that we have known for a long time of doing this, and yet we continue to go back and try to make our HVAC systems, you know, a little bit less horrifically inefficient. That's been our focus on that. Things that sort of like push on the extents of our disciplinary knowledge rather than operate within known territory. I will always be one of these that kind of harangues a bit on the facade because we've focused so much on the facade on so many different things. You know, whether it was the intelligent facade, double skin facades, climate skins, breathing skins, all of those different things that we want our facade to do. And you know, so I own all the books, by the way. You know, you name it, I have every book that was published on dealing with some kind of advanced smart facade system. Because when I first started teaching this class that Carl took, I was asked to teach a class on smart facades. That was sort of what I was drawn in to do that. And it just kind of, yeah, magic instead. You know, just kind of have morphed in that particular way. But even things that are so basic, and this next slide is going to date me. The people of my generation love a Carlos Scarpa building. But, you know, view and light, they don't belong together. You know, when we deal with floor-to-ceiling glazing and assuming we're doing view and light, couldn't pick a worse combination to do view and light. And I would say living in a high-rise in Austin, Texas, where we had, I guess it was 45 straight days over 100 degrees last summer, and realizing that everybody had floor-to-ceiling glazing. I live in an old building, 2006. That's an old building in Austin. All the new buildings, floor-to-ceiling glazing, all have full shades down all day long in order to deal with that. This is how you deal with light and view. They belong in separate locations, and there's so many things like that. We want everything to be integrated neatly together, tied in, collapsed onto a facade. Start thinking about sort of pulling those things apart. How do they really want to function? Where do they really want to be on that? And this is for some of the techier people in there. So much of our focus is on trying to design facades to save energy. Now, this is only from one building, but we fully outfitted a building at Yale with sort of an incredible sensor system. The idea was not to deal with a standard metric, but really understood precisely where we were spending energy. And so it was broken into sort of 4 different things. What are the types of things that the occupant is causing? And what about things that belong to an occupant? We charge a lot of things to a building, like electricity. Some of the electricity we charge at the building doesn't belong to the building. If I decide to bring a computer into the building or my own little personal refrigerator into a building, that's not about the building design. That's sort of what I've decided to do as an occupant. And it really shouldn't be about the charge to the building, but nevertheless, sort of understanding that. Understanding the actual equipment efficiency and the operational efficiency. What are the things that really are about sort of the interior design of the building? And that would be the interior lighting and the interior climate. And then what things were only about the envelope? Right now, we actually only calculate envelope loads fairly well. We don't calculate the other things. So in doing this analysis, the least important thing on there from an energy standpoint, the facade, the envelope. And yet that's where so much of our attention goes within this. Lesson number 2, this is my favorite one. Black box accounting has no place in science. We do black box accounting on buildings. We think about energy going in, and energy going out. Again, we served that drawing I had there. And what happens is that we end up truncating a lot of sort of like the impacts and the systems that we deal with. We're only looking at sort of a very narrow purview. Something like net zero energy building, which I'm sure everybody has heard of, that is a physical impossibility. It violates the most fundamental law of thermodynamics. There is no such thing. And yet we hear about it all the time. We're taught to design for it all the time. It is a physical impossibility. You could only have a net zero energy building if you leave out an awful lot of what you are accounting for. And I didn't realize this until about 6 months ago. I was trying to understand, why is it that we would even think of doing accounting at the meter? Why is that sort of a place we would do thermodynamic accounting? And it actually goes back to the 1973 oil embargo. What happened during the oil embargo, and I'm guessing there's like 2 people in here besides me. I was parked in a line like this. I had, my sisters and I would we'd each take a day. And one of us would have all of the family in the neighbors' cars parked in line for the entire day to get gas. And we actually had to go through this after Hurricane Harvey. We had it again. I got to deal with it just a year and a half ago. But the way that the US government decided to deal with this was to realize that they had to account. They were concerned about, national security. They were concerned about sovereignty. They were really worried about how they were going to account for who owned what fuel. It was all based then on where dollars were exchanged. That was the accounting system they set up. It's the accounting system we use today, which is why the meter, an electric meter or a gas meter, determines how a building uses energy. It has almost nothing to do with how a building sort of actually uses the energy or exchanges the energy, but that was the accounting system that was set up. And I don't think you can quite read it from this. This is what came from Congress on how to do this accounting. There's a sort of a little bit of thing that's difficult to read, but it talks about this kind of analysis which they were using to track fuel in this country, saying that you can always sort of aggregate larger, you cannot disaggregate. But we've been disaggregating. We keep taking it down. We keep taking it down on that. And so we look at something like this, and this is from the Intergovernmental Panel on Climate Change, looking at where greenhouse gas emissions take place. High-income countries, upper mid-income countries, low income countries. Bunkers are just things that don't belong to anybody, like maritime and aviation right there, so you can ignore that. And you think on here, if this is buildings, buildings aren't a problem. Except this part, which is electricity, that much of that is buildings. And industry, all of our materials that we use in a building are accounted for not under buildings, but under industry. So that is also buildings. So by the time you actually start looking to how much of this is about buildings, it's stunning. But because of the way this input-output analysis has been done, we actually leave out the lion's share of many of our consequences on that. So, but this is the part that means the most to me. The fact that the developing world's needs have to be front and center of what we do. And we start thinking about things like net zero energy or green premiums and things like that. We're thinking about our own world, our things that we make. I was very, very influenced when I began all this by Our Common Future, which is a report of the Brundtland Commission in 1987. And the Brundtland Commission had this definition of sustainable development that pretty much everyone has co-opted. You know, you'll see a version of it everywhere you go, and that's the first time it was developed like that. How we've co-opted it has nothing to do with where it came from, because what they were thinking about was the fact that sort of like it wasn't about the needs of the present or the ability of future generations to meet their own needs. It wasn't talking about my generations or my progeny. It was talking about the world's. So needs of the world, not compromising the needs of the world. It wasn't saying, oh, by the way, you can truncate it and you can look at it just for these people or just for those people. And yet that's very much how we've done that. These are the kinds of needs they were talking about. So this is a list that they had compiled that looked at environmental issues that they were concerned about and then developmental issues. And they were looking at the balance between those. You know, the fact that we had to deal with these sort of critical developmental issues at the same time we were dealing with the environmental issues. It was writ large. It was never meant to be sort of like parceled out. It was not meant to be about, I'm going to have a sustainable product. I'm going to have a sustainable building. I'm going to have a sustainable town. I live in a town that has its definition. It's about Austin. Probably the one that goes to the most extreme is Santa Monica, which has their definition, and of course it fits right in with their city motto, which translates from the Latin, a fortunate land for fortunate people. So sustainability, preserving for my children, not the world's children within that. I was so influenced by Gro Harlem Brundtland that on the 20th anniversary of the report, I invited her to Yale to lecture. And what was really interesting about this lecture is that when it was over, people in the audience kept asking her questions like, what if we just had more nuclear power? What if we just geoengineered the upper atmosphere? They kept peppering her with these questions like, there's an answer. There's got to be an answer. There's got to be a solution. Just tell us what it is. We want to know what it is. And she got very exasperated. And she finally said, this is sort of quoting from what she said, that really what sustainability was not sort of an achievable end. It was actually a process of making difficult decisions between things of all problematic consequences. And each decision that you make and each step that you took, you learned a little bit more, and hopefully you did a little less harm to the world. She says that's what sustainability is. Anyone who thinks that it's some kind of utopian end doesn't understand it. Half the audience was really dismayed by it. I'd say the other half was incredibly inspired, and I was one of those that was incredibly inspired. So here's my last little thing that I'm sharing, because it has nothing to do with architecture. It's somebody who's so fascinated me, and it's one of the reasons why I left the Ivy League to move to Texas. It has to do with sort of like learning to speak to other people. When you spend 25 years in the Ivy League, you're kind of in an echo chamber of people who think like you, and sort of like many of the things that we would talk about, we kind of had all reflected back. But I have to admit, I did hear this guy in the Ivy League. I heard this guy speak at Yale. His name is Dan Kahane. And he's one of those, and I'm sure you've read about this in a number of different places, it deals with cultural cognition. So here's this scientist that he takes sort of different things and sends them out to people. So here's a scientist who has said both of these things actually in the same paper. He said that it's beyond a reasonable scientific dispute that human activity is causing global warming. But then he's also said in there, judged by conventional scientific standards, it's premature to conclude that human CO2 emissions cause global warming. It sounds like it's contradictory, but he actually has an argument as to why both of those are so. So what Dan Kahane noticed is that if you, depending on which of these things you saw first and what your political beliefs were, well, whether or not you thought the scientist was any good. So if you thought that, for example, if you saw the first statement, that it's beyond a reasonable doubt, and you were a liberal Democrat, of course he's an expert. On the other hand, if you were a conservative Republican, say, of course he's an idiot. And exactly the opposite was true for the people saw the second statement first, you know, for the very liberal Democrats, of course he's not an expert. And for the others, of course he is an expert. So Dan had been doing a series of experiments over the years. Said a lot of people have been working on this, but he really focused on the kinds of things that cause a reaction. And so these are some of them. Global warming, private gun possession, I live in Texas. Fracking, I also live in Texas for that one. And what he realized is that your political leanings, on the ones that have, you know, a slope to them, it means your political beliefs radically change the way you read these things. Whereas if they're fairly straight across, your political beliefs have nothing to do with that. You're kind of in consensus within that. Now here's the part about it that's really interesting, is that we have, and I think every one of us who's an educator believes this, you believe that if you give out more information, if you teach people, if you educate them on risks, if you get the knowledge to them, they will come up with better solutions, or they will come to a similar conclusion. What Dan discovered is no. Not only that, but what's interesting is that the more you would educate people on a particular thing, if that particular thing rung a bell that was either political, moral, or religious, the more they would diverge. Because the more educated they were, the more able they were to cherry pick the things that resonated with their beliefs. And I've been fascinated by this. Absolutely fascinated by the fact that all the things that we're doing in our field, and it's not just the things that we're doing in our field to others beyond, but it's also how we talk about things within our own field. As someone who's worked in sustainability for a long time, sometimes the most difficult people I have to work with are the ones who believe deeply in its value. They do believe so deeply in its value that they also have a very strong set of beliefs about what's right and what's wrong. And it's very difficult to challenge that, because if you challenge what they believe to be right, then they think that you don't get it, or that you're not actually a believer in sustainability in the way they are within that. So it's an issue that we have both within our field and outside of our field. One of the things that I have really enjoyed about being at Texas is that, particularly being at a public university, I have to work with the state legislature and the governor's office. And it's been really interesting to me. There are people that I have had dinner with that I never, ever thought, let's just say, I never thought that I'd really want to be in the same state with them before, much less at the same table. And what we do is we really look for, you know, keep away from the things that trigger that kind of response. What's the common ground? And I don't care what they believe or what they want, but if we can get to sort of like an action plan, I'm all for it. And so this has been one of the most interesting things for me that I'm getting engaged in. I never thought that a year and a half ago, sitting down, I spend probably half of my time dealing with whether it's city council, mayor, or legislature there. Never thought I'd be doing things like that. And yet now I feel like I'm actually making a bigger difference than I've ever had to make before. But a lot of it is a sort of recognizing that, you know, this kind of triggering, this dealing with strong beliefs in terms of right and wrong. And that doesn't matter whether right and wrong is about whether or not that darn skylight should be facing north or south. There have so many things like that that are embedded in the way that we think about the things we work with. And it really does demand this stepping back and just sort of, how does this really work? And anyway, thank you all so much for coming on. I'm so sorry I couldn't find that photo. I know it's on here somewhere, but, and I would love to show it. I looked really good back then, so I would have loved to have shown that photo of me at NASA, but it's in a book that Lydia Calapoliti did, so you can always find it there. Any questions?
Well, thank you again. I'm going to hand the mic to Eric and let him do questions for us. And so we'll catch up.
Okay.
All right, so let me bring the mic around to whoever has a question. I'm sure you have one. Great. Who would like to start?
Hi.
Hi.
Is this on? Yes. Okay. Hi. My name's Janelle. Do you think that it's your background in science that gives you the sort of confidence and sureness about being able to question all these things that were sort of embedded into the way that we think? Or do you think it's like a component to your personality?
I think it's both. This is going to sound really, really arrogant, but I was a brilliant engineer, and I was considered iconoclastic at both NASA and DuPont, an oddball because of the way that I thought and that I worked. So I think that's a part of it. But I will say that probably some of it was just the education, and the education particularly that I had at NASA. My last job there, I was in a think tank. And I was surrounded by people who just spent the day wondering, how does this work? What could we do with this? The sort of freedom of not having constraints always stayed with me. So I think in some ways I'm a bad role model and a bad example because, I ended up switching into architecture when I was almost 40. And so, and I never developed as an architect as well as I had developed as an engineer because I came into it so late. And when you're 50 and you're graduating, you're thinking like, I don't think I really want to be an intern, type of thing. So I don't think that kind of track is meaningful for a lot of people. And I've really been wrestling then with, what kinds of sort of communications, collaborations do we need to have? So it doesn't have to be embedded in a person, but how do we really freely talk to each other and open up? I'm as much for, pushing engineers to be a lot more imaginative than they are, as I am for pushing architects to sort of like open up and really think about science deeper. Yeah.
So I wasn't driving in 1973, but I was around. I remember. Well, I don't know. I got all kinds of questions, but let's see. What should I start with? I wonder if you could comment on what architecture that's been done recently that you think maybe begins to move in a direction appropriate to your perspective, or do you think it's, or is there a particular practice or a way of practicing that you could describe that moves in a direction that seems appropriate? And you could pass on that if you
No, I'm actually not going to pass on that one. I have become really intrigued by the number of firms out there that have opened their own research arm. And, I find this to be incredibly compelling for a number of different reasons. One, I think, almost everyone knows we don't get money in this country to do much research, in architecture. It's not happening. And I don't think universities have stepped up to the plate here in the way that they should, although one of the reasons universities haven't stepped up to the plate is that there's also not money for the universities to do this. They would depend upon the kinds of federal grants that you might get that simply aren't there. The fact that we have many firms, and I actually did a symposium 2 years ago where I invited a number of these sort of different firms that were doing research. Most of them do materials research, so it's not as much it's not as much sort of, you're going to find it advanced research in, true physical simulation or modeling, but really good materials research. And I have seen some pretty remarkable experiments in there. And I love that kind of sense because it's something that wouldn't happen in the engineering field, the kind of openness to which this experimentation takes place. I think that's really healthy. I don't know how long-lived it's going to be because, ultimately, many of these sort of firms have found a way to have clients pay for things, and they're willing to do that now. But is this something that sort of became wider spread? I'm not sure that would necessarily happen on that. But I think that the kind of a landscape of having a lot of these sort of small, independent research taking place might be way more fruitful than actually having a big, massive research project. So I'm intrigued by that.
So maybe just like a follow-up question too, and this is a trick question or a loaded question. What's your take on the living building challenge?
I don't want to go there.
Just wanted to know her perspective on the living building challenge.
I think the thing that I have, I'm going to give myself until I die to keep working on this. Every new thing like this that comes up still sort of embedded in a lot of the same assumptions that they haven't been able to sort of like pull themselves out of in terms of how we understand systems. I think the part that hurts us the most within our field, but it's also almost inescapable, is that we always see through things through our fundamental product. And we sort of allow our fundamental product to define the way that we examine and we understand things. The real challenge for us will be to understand that fundamental product that we make. I mean, even though it's not a thermodynamic system and nowhere close to being a thermodynamic system, nevertheless, we still build in units of buildings. And so the question for us really becomes within all of this as to, how do we understand what we do as an intervention on something much larger? And the living building challenge is sort of struggling with some of those aspects, yet at the same time, it still comes back to being about the thing that we make, as opposed to the impact of the thing we make in a much larger way. And I know that doesn't sound completely clear, and I need to figure out exactly how to get that out there in terms of where we should be doing this kind of analysis so that it does. I'm a big fan, and there's a little bit of traction on this at the level of the Intergovernmental Panel on Climate Change, is that if we just started doing everything in terms of a radiative forcing analysis, that would be a way of challenging sort of like the idea that we think about it in terms of the objects that we deal with. But that's way off. We will already have our coasts completely inundated long before we figure out a better way to analyze this. So, yeah.
I have a pretty simple one that kind of relates to our studio course right now, like back to the 20 to 35% quote that you're going to. How do you stray away from, how do you pick out skewed information or stats? How do you figure out what is?
That's such a good question. It's something that, I changed a lot of my classes that I taught to spend the first part of them actually sort of tracking down information like this. And, and I'll have to give you another example because it's probably the first time I thought about doing something like this. But when I was a doctoral student, I got a job for the Defense Department to come up with a deployable, a hospital pod that was going to be dropped in remote areas. And they had a set of things that they wanted in this little hospital pod, and one of them was a smart toilet. And the idea of the smart toilet, as it was explained in the instructions for this, is that it did everything, including, it did full chemical assays, drug testing, and all this kind of stuff. And I had done a lot of work with sensors when I was still working for NASA, and I also worked with sensors a lot when I worked for DuPont, and I'm going, it was the same way, I do not know how this is going to work unless you're actually really controlling what kinds of things go into this toilet. I think there's certain kinds of particulates that would be very problematic for whatever kind of sensor system they were dealing with. And so, called back the Defense Department and said, I don't really understand this thing. Where is it? And they go, oh, it's a commercial product in Japan. And I said, well, can you send me something on it? Because I can't find anything. So they sent me a copy of, it wasn't a TED Talk, but something like a TED Talk where somebody had heard about it. And so I called the person who'd given the talk, and they go, yeah, they heard about it. They didn't remember where. So I went on from there, and eventually I found the original source of that. And it was just calling people, following up with people, looking at things like that. And it was a guy in, it was a Japanese designer for a company who said, in the future, we're going to have these things. So a lot of it actually is instead of finding, the first part of it is finding the original source, because we're bad about this in architecture. It's like we'll take the most where we saw it, not what its source was. So tracking things down, getting very uncomfortable if you can't track that back all the way in there. That doesn't mean, and here's the part that's very difficult, it doesn't mean that the original source is good either. The original source for information might also have been somebody who misunderstood something, miscalculated something, if you can't walk through the calculations yourselves. And I think that this is really tough for many of us in architecture. You can't go do that kind of deep checking on absolutely everything. But I think the very least we can do is at least go back to whoever wrote it or said it originally. The primary speaker on that is a good start on all of this. It's a pernicious problem.
Hey there. I had a question about your sustainability points. You said passive systems, best practices, and technological systems. I actually am also a musician. I play drums at a church, and the church was designed in the 70s when this passive system was the thing. And they told me the first minute that I walked in, they said the system was not actually working. So to the point 3, is there a point 4 for sustainable practices? Do you see where there could be a point 4? Or should us as students, should we be combining point 1, 2, and 3 as a design process for sustainability?
You're talking about the first 3 ones?
Yeah, you said passive
Oh, I was
systems.
thinking not doing any of those.
Oh.
letting those go. Form is problematic. We make form, and we want it to be about form. But form is highly problematic, mostly because when we're talking about energy use, most of the energy exchanges that we're dealing with do not occur at the scale of a building. They occur either, again, at micron scale, they might occur at centimeter scale, but they don't attach to the building. So form really isn't a way of doing it. I mean, yes, if you reorient a building, you're going to change a lot of things about the building in terms of radiation, but you're just doing so at a really gross scale. You could do all of that by operating at the scale at which it occurs as opposed to at the scale of a building. The best practices, I feel like the best practices keep us trapped in what we know. And they kind of keep us always never being able to escape that. If we're rewarding ourselves for doing that which we believe to be so, we're not opening ourselves up there. So, I was very mixed when LEED came out because of that. I became accepting of it when I realized it was like a lingua franca, that the one thing that was really nice about it is that we had a platform that everybody could talk about things with. I like that part of those kinds of systems, that at least we put everything on the table and we talk about things. But when it becomes something that instead is just like, this is my slate, this is what I work toward, then those systems are not great. And then the technological things, I think, are red herrings. For me, a lot of the energy systems that we put on buildings, a building's not an energy system. It's always a consumer. And it doesn't matter if the photovoltaic is on your building, is next to your building, is 50 feet from your building, is 100 feet, or 1,000 miles away. In the way that our energy systems work, who owns it doesn't get to count it. And yet that's one of the things that happens with a lot of these technologies that we purchase, is that the owner of the technology gets to sort of negate what it is they do. I probably shouldn't say this. I would hope it wouldn't be recorded, but it is going to be recorded, so I can't say it. But about a house that I visited last year. So I'm not going there because someone might hear about a gigantic house for one person, ultra energy efficient, net zero energy, because it owned every kind of advanced technology you could imagine. So I love technology. I love finding ways to make them more efficient. I love thinking about ways that we could do the job in the best possible way with the least amount. But when we start thinking it's a technological answer and it's not about rethinking the way that we design, we're kind of abdicating our responsibility. So it's none of those. So we got to come up with that point 4.
So my question is, I guess as a synopsis, saying that the general practices and avenues that we are continually driving ourselves down at a grand scale in architecture are essentially like red herrings. Like we're trying to find this building is 40% more efficient here, but in the grand scheme, that's negligible effect on overall sustainability. That sustainability itself is more, like it's not something that will be solved in architecture, but it's something that architecture will be part of the solution. But ultimately, the solution is a social function that will be brought about. That, like, it'll have to change at a social and personal level as well as at a design level. But I guess in one respect, I'm trying to think how to phrase this right. How do you mediate between the social influences and demands on what we're trying to design and implement versus the trying to push towards a real pushing towards a change in social event in sustainability within architecture? I don't know if that's clear enough. I don't know if I phrased that clear enough.
I'm thinking.
Don't worry, I'm trying to work it out too. Because architecture is a result of, it is a demand of social function. So how do we push architecture towards sustainability that is contrary to the actual social demand of sustainability?
Why would it be contrary to?
This will formulate it out a minute ago.
Let me just start talking, and then let's see if we start figuring out where we want to go with that. One of the things that I think would be really provocative for us to deal with is start looking at. It comes back to the sort of question about the unit, the building, about how we can think about this in terms of a collective public good. That, each move we make, it may be about this one intervention, this one unit that we're dealing with. How do we make sure that it has a collective public good? Now, this is an example that's not quite about building, but it relates to a project that I was involved with, and we were really unhappy we didn't get it funded, but in India, where we were going to work with private power. A lot of the transnational software companies in Bangalore were having trouble with the fact that the energy use goes up 10% a year. It's an astonishing rate of what's happening in a lot of the developing world, but in Bangalore in particular, because it's where so many software companies have settled. And these are all companies that were willing to pay for their own power, private power. So you think about something like that. Sure, you know, they're going to buy their own power. What a way to sort of really expand the gap between the haves and the have-nots. You know, that the software companies have private, uninterrupted power, and you know, and everybody else is sort of left on their own. And so we were looking at different types of technologies they could use that we could at least use the heat generated. It was actually, we're going to work with fuel cells. We could at least use the heat it was generating to clean water. And the thought is that, okay, we make the software companies have to buy the power, they get their uninterrupted power, but we're going to make clean water for a large part of the population. And I became really interested in whether or not you could have these kinds of binaries, that something that you know that whether it's the wealthy are going to pay for them, whether it might be the signature building that's going to bring that forward, that we could still sort of operate, you know, in one realm, yet at the same time always thinking about what that public good would be, which carries out what Brundtland really wanted everyone to do, you know, in the end, was never lose sight of the part of the world that was the neediest on that. I want us to start thinking like that, like what are those kinds of decisions that I could make and the thing I have control over, yet at the same time I know there's a greater good, and that greater good just isn't because I made a calculation that said I'm using less energy on that, but that I'm actually doing something beyond that. What are those kinds of systems?
And actually, in your response there, you sort of reminded me of what the original point I was trying to get at, and how I wanted to phrase it was, how can we use architecture, which, as you said, is inherently a drain, no matter what. How can we use that to push, I guess, social function towards something that is actually sustainable? So how do we take something that is a absolute negative and use it to push something towards the positive? And in your answer, sort of, you touched on that, and that's sort of.
And I think that's an incredible challenge for us. And I would hope it'd be more inspiring than anything else we could ever imagine as architects, is sort of thinking that what that is beyond that thing that we make, what it does.
Thank you.
Well, thank you for helping pull that out.
Oh, I just have a quick question. What journals do you read, and what journals would you recommend for the students to read?
No, I was going to say, now that I'm a dean, I'm having to read the journals for all the people that are getting tenure and what they're writing for it. So it's mostly transportation planning on that. I will say.
There's nothing that comes to mind.
No, I will say that.
Maybe there aren't journals, maybe that's part of it, right? And without an industry for this.
Yeah, right now I'm reading all this Texas fiction. The Sun is fabulous. There's a television show. I'm a huge lover of science fiction. Always have been. But I also, almost anything. When I was a student, when I was a grad student, I used to go to the medical school to listen to grand rounds where they talked about medical cases, because I had no desire of ever being a doctor, but just to go over there. Being part of it being an architect in the better shoes was another reason to go over there, to show off shoes. But nevertheless, it's anything that takes me out of my normative thing. So I don't read as much in my own area as I do in other kinds of areas. Yeah.
I'm Ash, I'm a professor here. I was influenced as Carl with one of your lectures way back 18 years ago at University of Michigan that made me go against my advisor at that time
And I know him, so
yeah,
good move on your part, yeah.
get off the artificial intelligence knowledge-based design into sustainability. And my question is, why you are saying, I understand the argument, there is no net zero energy buildings, because buildings are always, as you said, consumers of energy. But how you describe these highly efficient building, LEED Platinum, Michelle Addington version of name to a highly efficient building?
You know, if I were a better architect and I wasn't dealing with difficult faculty every day in my job, the students are amazing, by the way. And I hear the same thing from Carl, not about difficult faculty. I only hear about how great the students are here. I had always had a great interest in this sort of idea of not highly integrated, but highly decoupled. That thinking about sort of like disintegrating every system into sort of a single function. And this all also comes from my NASA background in that I was really influenced by a NASA administrator who was talking about the early Mars rover, long before what we're dealing with now, says that, you know, a really good design is one that's fully disintegrated. Nothing gets integrated together because failure becomes more catastrophic the more integrated. And of course, when we look at buildings, we also start going to the lower common denominator. When we start integrating multiple things together, we start doing so sort of like at less effectiveness. So I've really been interested, what are the things that I would identify that I most sort of want to have, beginning to decouple them. I think about buildings as things that should be lighter, and I don't mean lighter in terms of weight or light, except in many ways I do, but stripped of so much of this kind of extra stuff that we're adding them, and that many cases is there to compensate for the very clumsiness of the systems we decide that we need to have. You start thinking about what the body actually needs in a building, it's surprisingly small. You know, what the building needs in order to make the environment is surprisingly large. But the body doesn't need that environment. What the body needs are actually some very discrete moves that are really quite astonishing. I work a lot with students over the years on just how the eye works. You know, again, we would never think about it. The history of how we ended up with lighting in the ceiling is even more bizarre than the history of how we ended up with this sort of crazy HVAC system. You know, we see with micro rifts of luminance, designing the micro rift of luminance, you know, how a photon strikes the eye in order to see, designing, you know, for just radiation on the carotid artery, you know. I'm fascinated by this. So for me, it's not thinking about the LEED Platinum, highly efficient building, you know, with a variable speed drive for the fans. It really is thinking about that fully decoupled type of system where the technologies are discrete, they're direct, and they're small. That's what I want, yeah.
Other questions?
Oh, we're still looking at this, huh?
What inspired you to pursue architecture?
You know, then sometimes the questions get really personal. And I have the cheesiest story ever for this. I started as a music major, performance anxiety, and I went to my second great love, which was math. And from math, I went into physics into nuclear physics, nuclear engineering, then into mechanical engineering. And I really loved being an engineer. I really enjoyed it. And I was happily doing it. The only thing I didn't love was my mother-in-law. And my mother-in-law lived in Pittsburgh. And for some reason, we had to visit an inordinate number of times. And I didn't understand why we had to go to Pittsburgh, once a month. And I tried to find something I could do, and it made her happy too if I was going to be gone for the whole day. Something I could do that I would be gone from my mother-in-law for an entire day. And I found a day trip that I could take. It was to Falling Water. I went to Falling Water 25 times. And my mother-in-law, why do you have to go there? I made up that I wanted to be an architect, just so I could have my excuse to be away. And then I believed it after a while. I've never regretted it. I often tell people I went into architecture for the lower pay, but the reality is I feel like I'm the luckiest person in the world, that I got to make that change when I made it. So yes, that's what inspired me.
Other questions? I have one, actually.
Okay.
Conceptually, as you get into the conversation about sustainability, do you find other ways to describe it as more effective, to sort of jump people out of their way of thinking, like, for instance, resiliency? Instead of saying sustainability, let's go for a bigger concept that subsumes it or that is somehow different from that.
Yeah, I think this is part of what we're going to have to do more and more of. It's something that I've really enjoyed about being in Texas. It's finding the language that you can get everybody at the table. Yeah. And if you're going to talk about controlling fossil fuel in Texas, you're not going to get everybody at the table. Particularly at a university that most of our income for the university comes from, fossil fuels. On the other hand, everybody will sit at the table if you talk wind power. Texas is the biggest producer of wind power in the country. Doesn't matter, you could be the reddest Republican or the bluest Democrat, you love wind power. And so if you start talking about distributed energy and energy generation and new types of ways of delivering that energy, if you call it renewable energy, people start to split. You talk about we're first, we have the most wind, people sit at the table. And I think resiliency is going to be one of those words. We have a massive research project at the university that involves most of the schools, 100 different researchers, and it's funded for 10 years looking at resiliency in the state of Texas. And so we've also been talking not so much about climate change, we talk about catastrophic storms. Everybody will come to the table if you talk about how we prepare, what we have to do in order to prevent the impact of a catastrophic storm. Yes, a lot of those things will be reducing greenhouse gases and things like that, but finding that kind of language that doesn't get people to sort of like immediately retrench is really key within it.
Is this the action plan you were talking about, finding a way to get to an action plan in some sense?
Yeah, I mean, that's really, if you really care about your field, it's more about getting people to the table and getting something done than it is making sure that they all sort of like are on your side or believe in what you believe in. I don't care what they believe in. I care that we get something done.
Wow. Okay. Any other questions? Thank you so very much. That was
this was really fun. I love the questions. I can't believe I got through the whole thing without needing a cough drop. This is so